Hi, my name is John, amateur radio call sign M7CPT. In this video, I'm going to be taking another look at the Diamond WD-330S, just to see if there's any way I can improve its performance within the limitations of my garden space. And with that being said, welcome to amateur radio on the air. Hi. For anyone that wishes to see my review on the initial Diamond WD-330S, I'll post a link up in the corner so you can go and see it if you wish. Now, I was impressed with the speed that I could switch bands and tune the antenna. Also, I found that 30 meters and above, it worked terrific both on transmit and receive. Now, what I'm exploring in this one is, can we get it to work better on the lower frequencies without too much alteration? One thing I noticed on the previous video was how close the resistor was to the balun. Now, originally I thought this was just a space saving idea, but I've since then made a more exact version of the model where you can see it's brought the resistor down towards the balun with just a small gap between the wires. If I go to the calculations at this point, I'll just quickly run through some of these. Now, if you look at the gains, they're actually higher. So something's going on within this section that's improving the actual output, but I'm still not sure as to what. I suspect it's something to do with the capacitance between the two wires, but I don't know. I just thought you'd find that little detail interesting. If you remember from my previous video, the measurement at 30 meters was minus 13.44 dBi. Now, if we can get something close to that on the top band down here, then we should have an antenna that is workable on all the bands with various levels of gain. That's my theory. And let's see if the modeling plays out. So first of all, I select the lowest frequency possible and just let the program do the optimization. We want the best gain the lowest SWR, all elements. Let's see what the program comes up with. Right. So now we know it's possible on top band to have an SWR low enough to tune with a dBi gain as low as 4.75. But now let's look at the bad news. Well, as you can see, 72.8 meters from the balun out to the ends. It's 145.6 meters, and the height 7.28 meters. That's not practical in my book for any use. So let's just close that, and I'll show you one of the other configurations I've tried. This one is basically the same length, but the height has changed. The height I've taken to just 3 meters, but it's still just short of 10 meters long. Now I have the SWR less than 2, so that's good. And the gain minus 38.2. This will be a possible thing to work with. This may give us just enough to work the 160 meters. My next idea was to keep the overall length at 10 meters, but open up the width, or the height of the antenna. So instead of having the half meter gap, it had a full meter. Now on this one, let's see where that gain matches out. You see, we've already made the 80 meter usable just by adding a little bit of extra height to the antenna and moving the resistor away from the balun as it was in the original design. Now, all we've added is half a meter to the height. Most people would be able to do this without too much of a problem. My next thought was, what about a delta loop that was terminated? Could that work? Now the geometry was the 10 meter length, and this time I set the height at 3 meters. Still not giving us 160 yet. but it does give us a better signal on 80. So 80 is definitely usable in the Delta configuration. Going a little bit further on the Delta configuration, I ran the auto calculation. Came out around about 82 3/4 meters with a 3-meter height. Not really very useful for the majority of gardens, but as you can see, 160 meters is extremely useful, and you're only losing 7 dBi on gain. So considering the space that I have available, I think these two are the prime candidates. I'm still not sure whether I'll go for the heightened T2FD or the delta formation. When it comes to the actual figures, the dBi gain is minus 38 on the widened T2FD, but in a delta formation you'll get a little bit more loss, but it's nothing major. I think it would still be workable. Now, if you look at the far field plots, they're both pretty much identical. Working envis wouldn't really make a lot of difference. Let me just change the elevation. And when it comes to working long distance DX, or as long as you can get, you see again, there's very little difference in them, just 4 dB, 4 dBi. Oh. Actually, let me just move my head out of the way. There. As you can see, 5 degrees above the horizon, on the traditional oblong shape, we have minus 40 dBi. But on a delta formation, we have a minus 44 dBi, which the two are still very close. So I think I'll probably end up going for the delta formation, as it should be easier to set up, and the far field plots don't really show much difference. Even when you go to the 3D versions of the far fields. Now, the balun and the resistor remain unchanged. They're still going to be the original Diamond WD-330S versions. Now, if somebody required more power, they would have to be changed. But for my power requirements, because I'm a foundation in the UK, I have a maximum 10 watts, so I'm well within the maximum for this antenna, so I don't need to change them. If you like the video, please click the thumbs up. If you have any opinion on either of these two options, please let me know, especially if you can think of another formation that may work even better. I'd love to hear your ideas before I actually start putting the work together to actually attempt something. And don't forget to subscribe and hit the bell icon. That way you get notifications each time I do uploads. And as I've already done, not all of my uploads are shared to the social media sites. So if you're not subscribed, you may miss out. And all that leaves me to say is, catch you on the air.